Hello everyone. Hope you all are enjoying sessions today. I'm Archana Agivale and today I will walk you through how we can combine the Nextjs static site generation using dynamic content update capability and our custom ISR structure. Before we start, let me introduce myself. I am a full stack developer and a tech lead at QED42. I love to open source in frameworks like a Nextjs and Strapi. I'm a core contributor for Nextjs and Strapi as well. Since years, I'm working with QED on very performance heavy websites and content driven applications. One challenge that we face is when editors are updating contents very frequently, your sites are getting slow. So with SSG, many people face that when you allow SSG sites to editors for updating content frequently, it will be not good solution. So in a QED42, I get a chance to tackle this solution with the help of mixing the static site generation, then build automation and event-driven architecture. So today I will be sharing the result of our journey, and actually we face this issue with one of our clients. Before we start, let me walk you through today's agenda. I will start with overview about SSG, then why SSG is very popular with static site and fast performance site. Then we'll see the challenges that we faced with SSG. Moving forward, many of you may know about, and as Tapas gives the bit background about ISR, so we'll walk you through the ISR. Then what are the challenges with ISR, where we can use the ISR and where we cannot use. Then we'll break down our custom ISR structure into the multiple state. And finally, we'll go with what's the impact in real world. So as we see the agenda of today's session, so let's understand what problem we are trying to solve. So let's see the real issue of static site generation. So static site generation, when we trying to use with a content driven application, it's a little bit slow. So think like you have one website which has the hundreds of articles, and now suppose your one of editor change one article, or maybe it might be one type of fix. So that one tiny fix will force your whole website to go into the rebuild process. It will regenerate all the other pages which ever not change. So does SSG sounds good for like a content applications? I guess answer of this might be no. So today we will try to solve same problem with the help of, as I mentioned, with our custom architecture. So before I go into the actual workflow, let's overview about SSG. SSG is a static site generation where your HTML is getting generated at the build time itself. So whenever user requests for the page, it's instantly served. So it's a very fast. As it's very fast, your SEO value is automatically get increased, right? And you can use SSG in maybe landing pages sites and documentation sites. But here is the one issue with SSG. As I mentioned, if your editor wants to change something, your site needs to go under the rebuild process. Now consider within a 5 minutes of time frame, your 5 editor or maybe one editor update some articles like a 5 times or 10 times. So you can imagine within a 5 minutes of time frame, your whole websites need to trigger the 5 or 10 rebuilds. Isn't it sound good? It's not efficient. So we can say the SSG is giving a great performance and speed. Still, it's have some bottlenecks in a content driven architecture. Many of you heard about ISR. So some might of you thinking that we can use ISR, then why should we use SSG? So ISR is something extended version of SSG where your page is getting a rebuild or regenerate in the background. It means when editors update any content and then suddenly some user wants to access that page, your cached page will serve to that user, and your regeneration process is happening in a background within that validation time frame. After the validation time frame, when some users are requesting for same page, they will able to access the updated content. So ISR is okay, but it's not a real-time application. So again, there is one issue with ISR. As I mentioned, we want to implement static site. So ISR required the server. So if your website is deployed on maybe CDN, CloudFront or S3, because these all gives you a very good performance. So if your site is deployed on consider CDN, then there is a no server. So ISR won't fit for your problem. So then what's the problem? You guys can think maybe we can use any other like a SSR or something. Then again there is a server problems or hosting issues. So what if we merge SSG with a validation process of ISR? There is where we come to the solution that we merge SSG with our custom ISR structure, where we actually implement what ISR doing, that is revalidation process, with our custom architecture. So let's walk through the workflow that we follow for our custom architecture. So our process include the Strapi webhook, then API gateway, SQS, build process, and cron job. So it's like we'll get the things modular also, cost effective, and then it will give you real time notification what's contents are getting updated. So our first step is a webhook. So many of you know that webhook is something, the messenger between CMS, you can say CMS and front end. So in our case, the webhook is the messenger between our Strapi's ecosystem and our Nextjs front end framework. So whenever there is a content update change happen in a Strapi, so simply it call one HTTP post request, which is our webhook URL, and then what contents get update will know into the API. So suppose editors update any article maybe, so our webhook will call API with the payload of content type, ID, what's get update, whole information will get into our API. So we can simply say the webhook is the messenger between Strapi, and it's the first step of our event-driven architecture. So in Strapi, we can simply configure the webhook. We need to just go to the Strapi admin panel, just go to the setting, then webhook, just hit the create custom webhook, add whatever name you want to give, and then you can see there is one URL. So URL is the main API where we had whole the logic what we want to do with our build and front end application. So in my case, I added the URL as a slash webhook, and you can see in the bottom there is a events. So events means whenever content gets update, delete or publish, what if events happen with content that we will notify, then only our webhook will get triggered. So like if any articles gets added, then only your webhook APIs gets called. So our next step is a API gateway. As I mentioned, our process is in a API gateway. So API gateway is the entry point of our custom architecture. So there we'll get what content is getting changed. So webhook will call our API. In API gateway, we'll got the content. What contents is getting update, we'll validate that content, create some consistent payload, and we'll forward that payload to our next step, which is SQS. So simply I can say the API gateway is scalable, and it separate out our front end and build logic also with CMS. So our third step is a SQS. Many of you work with a SQS might be. So SQS is a simple queue service messaging managed by the AWS. So why we use SQS? So suppose when something get changed, content get changed in a Strapi, it will trigger the API. If we get payload in an API and we immediately trigger the build, then what's difference in our architecture? So simply we are not triggering any build in API gateway. We are just saving payload in a message queue. Whatever payload we are getting, we are saving that payload in a message queue, and after some interval we'll work on that. So SQS is even if your build system is offline, your SQS will store the all data or all updates in its queue. Moving forward, the next step is a cron job. So cron job is simply, we all know it's a scheduler kind of thing. So after every interval of time, some specific interval of time, your code will get rerun. So cron job is doing a crucial role in our system. So in our case, we set cron job as interval as a 15 minutes. So after every 15 minutes, cron jobs get start to pulling data from SQS, and it check whether there is any messages in a SQS. If yes, then it will process further. If no, then it simply exit. No build gets triggered. So if there are some messages, then cron job will fetch all the messages and understand what changes are there. Is it require full build or is it require partial build? So depending on the messages or depending on a data, cron job will create the script and it will submit to the next process. So as I mentioned in a SQS, we are not triggering immediate build. So why we are not triggering immediate build? So if consider in 10 minutes of frame, the content updates get changes 10 times. So you can imagine 10 builds will get triggered. So you can imagine the resource utilization for that 10 builds is very high. In some cases, your system get crash also. So that because of that only, we are not triggering any immediate build. Rather, we are collecting data, and after some time, we are scheduling the build process. So we are working with a batch process using the cron job and SQS. So our last step is a build system. As in a cron job, we know what we need to do. Like we need to go with a full build or partial build. We are in the last step where we actually run the build. So every content not need a full build. Like if you can imagine if header and footer getting a change or navigation data is getting a change, in that case every page of website is getting affected. I can understand that in that case we require the full build. But what if only article title is getting a change, or any small typo or tags of articles are getting a change? In that case, we really need a full build? Answer for, I guess this everyone know, it's no, because we don't need full build. So in that case, we'll go with a partial build. So partial build is very efficient. It will save your time as well as your cost. We can see later in the slide that how impactful partial build is. So now our build script is ready. We know we need to do partial build or full build. Now it's time to just build your website. So we'll build our website. We simply push our output directory to served directory, which might be a CDN, and your content is live now. So when we do partial build, the some amount, like if whole folder is not getting updated, some routes are getting updated. In that case, we just need to copy paste that routes into the served directory. So I guess with partial as well as with full directory, there is a no time downtime. Also, it's a very cost effective. As we see how partial and full builds are useful, now we can walk through the real world example. Like I created one small demo which has the 1500 plus data, where I just simply write articles with title and description. No heavy content, images, or maybe CSS file. There is a nothing. So I simply created one flat site which has only title and description. So for full build completion, it took around 40 seconds. And for partial build, like if someone changed one article, two article, in that case, it's only took 9 seconds. So you can see how efficient is it. Like your partial build time is 4 times lesser than your full build. So in many cases, like with one of our client, the full build was taking around 15 minutes. So you can imagine that 15 minutes within the 10 minutes of time frame, with someone updates the data 10 times, that 10 builds triggers, then each builds require the 15 minutes. So because of that, we implemented the partial build. So the overall impact of ISR is we are using SSG only. We are not going with a server side rendering or something. So as it's serving the HTML, it is a pretty much slow. And everyone knows the search engines loves the static HTML. So because of that, the static HTML and page speed, your SEO will be automatically improved. No more full site rebuilds every update. As I mentioned, every update does not require a full build. So you can go with a partial build, which will save your time, deployment efforts, and then cost as well. Decoupled from deployment cycle, like many times when content change, the editors depends on devs, or maybe not devs exactly, but editors depends on CI/CD pipeline. When CI/CD pipeline gets triggered, then only contents will get live. So in this case, editors don't need to depend on CI/CD pipeline or devs. The scheduler will do their jobs and the content will get updated after some interval of time. As I mentioned, we don't need any server, so obviously it's in a lower hosting cost as well. So final takeaway for this session is just don't go with your traditional deployment process. Rather, just think out of the box. We can rewrite our deployment code and we can do something interesting to maybe save your cost, save your time, and save your manual efforts also. With the help, with the mixing of, with the picking something good from a static and something good from ISR, we generate some excellent and flexible solution. Then ISR plus webhook plus SQS, that is combination of ISR, webhook and SQS, which gives you a great solution where you don't want to really go with the immediate build trigger. It's a scalable solution, and not last not but least, like a devs and editor are not depend on like each one, because many times we face developers are doing their work, but in between they got just trigger the build. Editors are like messaging just trigger the build. It's like a pretty much not good experience for us as well. So guys, thank you so much. You can connect me on a LinkedIn. I hope everyone enjoys.